So basically, this is about instrumentation and measurement. Okay, and for the instrumentation system, so we need the instrumentation system to do the measurement. All right. Why we need to do the measurement? Because there are two things. So why we need to do the measurement? You just imagine that when you go to the mall and then there are one instrumentation, we call it is temperature detector. So that is the instrumentation, right? So what it we do is used to measure our temperature. So why we want to measure our temperature? We want to monitor our temperature, right? Whether it exceed the threshold or not. And one is the keyword is monitor, okay? And then the second word is for the safety purpose, all right? Betul lah kan? If you feel demam nak tutup, right? Not feel uh, apa panggil ni lah very well. So that's mean you cannot enter into that mall, right? So that mall or premise use the instrumentation for two purpose: monitoring and also to for the safety purpose. Okay, alright. So let's look another. Let me recap back. So we have learned a little bit about transducer. Okay, this is your transducer, and then it will go to the signal conditioning. Okay. Oh, okay. Right. It's a signal conditioning. So if you have the transducer, for example, normally it detect the temperature and then it will produce the voltage. And then for the signal conditioning, maybe you can amplify it, right, to become a voltage. And also there is some of the transducer is detect the uh, temperature and it will convert into ohms and then you can get it in terms of voltage. And maybe you need another signal conditioning to convert it into voltage. Okay. Alright, so we have learned a little bit about signal conditioning. The basic one is the voltage divider, and also we have learned about the concept of loading, which is quite important to know the concept of loading. So if you uh, uh, normally the transducer will have some internal resistance here. That means you cannot get yep, uh, the output in terms of 100% ideal output. And then when you attach with the signal conditioning, we also have some uh, resistance there. Okay. Alright. So this is just some explanation about on what we have done so far. Okay. So we are at this stage currently at this stage signal conditioning. Okay. So we want to learn a little bit about signal conditioning more. So what type of signal conditioning? And then after that we will focus on the what type of the signal, what type of the transducer. Okay. Right. Before that, do you have any question regarding this subject or regarding a previous lecture? Ada apa-apa soalan?
Tak ada.
Tak ada eh? Okay. Can I proceed for today's lectures? Boleh ya?
Boleh.
Okay, okay. Thank you very much. Alright. Um, we still at the signal conditioning. Okay. As we know that the signal conditioning have several objectives, several purpose. Alright. Uh, let's look the signal conditioning. What we call it? Operational amplifier. So the word is OM. So what the OM can do is first it can amplify and it can attenuate. Sometimes the word we call it de-amplify, de amplify. Okay, attenuate. All right. So what is mean by amplify? That means if you put it here 2 millivolt, and then it can amplify, it can become 2 volt. Okay, milli, and then it can become 2 volt. So that's the amplify. If the attenuate, that's mean you put it at 2 volt. Now it can attenuate, maybe it can become back to 2 millivolt, right? Okay, so the ideal amplifier has the infinity input impedance. Okay, this is the word, input impedance. So inside the amplifier or OM have this input impedance. Alright, and then the value is can go to infinity ohm, very big value, right? Why? Because this voltage, right? We try to separate the voltage with the voltage. Okay, and then it will have the output impedance. This is the word output impedance, which is equal to 0. Okay, and then at this side it will have the gain. Okay, this one is the gain. Right. So the gain is depending on the value of the resistor. We will look into that. Okay, so what it will get it here is we can get it the V out, which is the VO. So equal to gain, I put it G equal to VI. Okay, normally this is the standard equation for the OM lah. Okay. Right. So OM can configure as a voltage follower, inverting, non-inverting, and so on. We will look detail about it. Okay. All right. And it also can perform arithmetic of operation like addition, subtraction, multiplication. Okay. Uh, Sometimes we want to make an alarm system, so maybe we need some subtraction, for example. Okay, sometimes we want to edit more input signal, so we can use the multiplication, for example. Okay, all right. uh, this one is only the uh, so I call it theoretical about the OM. Okay, so there will be some voltage saturation, okay, for the OM. Okay, this is the OM. And then it is have the supply voltage, for example 5 volt, right? So this one you have learned in the lab 1. So for example, if you put it is 1 volt, okay, so maybe your gain now is equal to 1, so you can get a 1 volt. Okay, I put it 2, gain equal to 2. Okay, you can get a 2 volt. So if you put a 2 volt here, in theoretical you can get a 4 volt, but there will be have some we call it saturated. So in practically you cannot get a 4 volt, you will get a 3.8 volt. So this what we call it is saturated value. So in order to solve the saturated value, you can increase the input voltage to the OM. Okay, all right. uh the important thing about the OM is the symbol. So the symbol is start from negative here and positive. Okay, so please remember this one. Alright, this is the example the OM lah, 741. Currently there are a lot of OM in the market. Okay, that's like I mentioned it before. OM can be configured at the different configuration. For example, like this one, multipolar and so on. So we we're going to look one by one. All right, the OM configuration. First, inverting amplifier. Inverting amplifier. The configuration is shown here. This is the OM. Now you need the two resistor R2 and R1. R2 we call it a feedback resistor, right? From the output it goes back to the input. Okay, this is a feedback. And then this one we call it is input impedance, right? This one input impedance. Okay, so what it do is you can configure it as the amplify or attenuate. So what it do is if you give the voltage here, for example, like here, the graph show that okay 1 volt. Now your gain now I put it is equal to 2. That means you need to time by 2. So output you we got it is 2 volt. Okay. But this inverting OM will have the we have okay, we invert it. That means from positive, so if we invert it, it become negative. That's why in this graph you will see that your input is at the positive cycle. Okay, this is a positive cycle. Now if we invert it to become a negative cycle. Okay, this one positive become a negative. Alright, and this one negative become positive. It will amplify, right? But it will invert it. Okay. Alright, this is the basic uh, configuration of the inverting amplifier. Okay. So far, do you have any question? Is it clear to all of you?
Clear, Dato'.
Okay. Uh, do you got this note right? The student note, or you got the lectures note?
Ada.
Ada Okay, okay. Who's there? Rizwan. Oh, Rizwan and Aizat. Rizwan and Aizat. Where is everybody? Huh? Okay. Usai. Okay. Maybe you don't have any question yet. Okay. Uh, let's derive the equation for the inverting circuit. Okay. This is the basic one lah. So, remember for the inverting circuit, inverting amplifier. So what you will need have is you will have the OM, right? OM. Okay. So the word is positive is going to ground, and then it will have a feedback resistor here. Okay, and then you will have the input here, and this is the I put it. This is the V out, and then this is the V in. Okay, alright, and then you will have the feedback resistor. I put it is R2, and this one is R1. Okay, and then inside this one we got it is gain. Okay, alright. So that's a few parameter about it. Okay. So in order to derive this one, we will have the current is come out from the OM is IS. We always equal to 0. And then we also got it the current from the input I1, and then current from the output. Okay. So this one. Alright. Okay, so how to derive the equation? So I will show you first. Okay, so by using the Kirchhoff law, so we know that the current that going to one node, so this one we call it one node, is equal to 0. So I1 plus I2 plus IS equal to 0. So because of the IS equal to 0, so now we can get it is I1 equal to minus I2. Alright. So in order to find the I1, we can put it here is I put it is V minus. So this one is V plus. So we got it is here is V in minus V minus. You divided is R1. Okay. Alright, this part. Okay, we're going to find the I1. Okay. And then is equal to minus V out minus with the V minus divided with R2. Okay. Alright. So when you look at this, so V plus equal to 0. Why? Because it's shorted to ground. It make the V minus equal to V plus is equal to 0. Okay. Alright. So V minus will be equal to V plus. Okay. Alright. So in this case, what you have is V in divided with R1 minus V out divided with R2. Now we can get the equation V out minus R1 over R2, you find it being. Okay. Now in this case, So you can get it is, I put it here again, minus R1 divided with R2. So this is the formula for the inverting. Okay. Dan, sudah habis salin? Not yet.
Dah.
Amboi dah. Mesti dapat apa lectures note ni. Ha? Eh. I know some of you already got the lectures note before, okay, but I hope that you can do it again lah to make sure you can understand. Okay, all right. So let's look. Uh, as I mentioned before, this inverting it can be configured as the amplifier or attenuation. So in this case, let's say we want the gain for this one. We want is 100. So now I need to choose the R1. Oh, kenapa? Why? Okay. So now, sorry, this one. Now is R1. Okay. Di padam ni R2, R1, R2, R1. Okay. So, R2, R1. So in this case, we want to configure gain is equal to 100. So what can we do is we can choose the value of R2 is equal to 100 kilo ohm divided with 1 kilo ohm. Okay. Right. Then you will get your gain is equal to 100. Okay. That means you will play around with this resistance value. Okay, R2 and R1. If you want to make it is attenuation, for example, you want to put it is attenuate. That means divide. You want the gain is 0.1. So now what you can choose is you can choose what is it? 1k. I choose it 10k divided with what? How many? 100k, right? Okay, so that means this the value of R2 and R1. R1, R2 equal to 10k, R1 equal 100k. That one for the attenuation. Okay, so far any question? Ada apa-apa soalan? Tak ada. Okay. Any question, guys?
Tak.
Tak ada Aizat, tak ada apa soalan?
Doctor, I have a question.
Tak ada.
Yes, good. Kusai, why is it?
For 10k and 100k, can't we choose 1k and 10k?
Yes, sure. The question from the Kusai is, can we choose 1k, this one? Can we choose 1k and then this one is 10k? Yes, sure. You can choose any value. But try to choose kilo ohm. Why? Because we have looked the previous lecture about loading effect. So if you choose very low value, that mean you don't have K, so you just choose ohm. So it will consume a lot of current here. Okay, right. Try to choose kilo ohm. Okay, good question. All right, next we move to non-inverting. Okay, there are the second configuration of the OM. We can do the non-inverting amplifier. So in this case, the concept is when you put it is 2 volt. For example, my gain I set is 4. Now you can get it is 8 volt. All right. Really? No. Okay. You got it is depending. Yeah, depending. Yes, correct. Is at word. Okay. And then when you look at here, you put it positive. Now you can get it positive. So that means the it will not invert. That's why we call it not invert, non-inverting. If you give the positive cycle or positive voltage, then you got it positive voltage. Okay. You give it negative voltage, now you got it negative voltage. Okay. Right. This is the calculation on how you're going to get this equation. So let's look about this equation. You we got it is V out here equal to 1 plus R2 divided with R1, then you need to time with V in. Okay, so that's mean the gain is 1 plus R2 divided with R1. Alright, so for non-inverting, it cannot be configured as the attenuation. Attenuation. Do you know what I mean? That's mean if you want to make it the gain, right? I can put it here. You want to make the gain is equal to 1 divided by 10, which is 0.1. Okay, so you cannot get the value for the gain is 0.1 because of this one, this guy, 1. So the gain that you will get it is will be more than 1. So maybe 1 plus something, right? Right, because of this one. So that's why the non-inverting, it cannot be used as the attenuation purpose. Okay. All right. So far, do you have any question regarding this one? No. Clear, right? I think you already learned this one during your electronic subject. Okay, so let's look example 5.2. Okay, 5.2 is quite simple. Show how OM can be used to provide an amplifier of gain plus 100. Then the input signal has an input impedance of 1.5 kilo ohm. Show how this can be done using both inverting configuration and non-inverting. So we're going to draw the inverting circuit and non-inverting. Okay, and the keyword is the gain equal to plus 100, and then the input impedance is equal to 1.5 kilo ohm. Okay, all right, so this is the two information that we need to settle. Okay, all right, so let's do the inverting first. All right, inverting, so what you need to have here is you withdraw first the circuit, right? So remember the triangle minus and plus, and then plus we going to ground, and then it will have the feedback resistor here, and then it will have the input here. And now I put it here, Aizat, so what color that you want me to choose? Aizat ni mesti pink lah, pink ya. I know.
Purple.
Purple, bukan pink ke? You always
Bukan.
like pink, right?
Mana ada.
Alah, tengok gaya pun dah tahu dah. Okay, this one, alright, V out. Okay, this one is V in. Okay, this one is R2 and R1. Okay, done. So we already draw the circuit for this inverting. Right, so this is the gain, right? Uh, okay, the gain, okay. So this is right. So the purpose is we going to find out what is the value for this one and what is the value for this one. Right? Okay, based on the question. So we can write the formula that involved in this one is minus R2 divided with R1 with time with B in. And also your gain is can be minus R2 divided with R1. Okay, so you are given the gain is 100 equal to R2 divided with R1. Okay, all right, in this case there are one parameters that are given, which is input impedance. So for this case, for the input impedance for this one is equal to 1.5 kilo ohm. So that means we already know the value for this one. So we can find the value for R2. R2 divide with 1.5k, and then you can get the R2 value is equal to 150 kilo ohm. Okay. Now we have achieved our objective. We have found this value. Okay, done. All right. However, right? So, uh, yeah, this one is got the minus. Okay. So, however, the question asks you to get it. The gain is plus 100. Okay. The keyword is plus 100. Right. So, if you uh, at this stage, right? At this stage, you will get it. Is the gain is equal to minus 100. So in order to get the positive 100, so you need to put it another amplifier. So let me draw it again. So this is your amplifier, inverting amplifier, invert. Okay, then this one your R2, R1. So this is the V in, this is a V out. Okay, now we already got this value 150k, 1.5k. Then we already got this one. However, our gain is minus 100. Now we need to have another amplifier, inverting amplifier. Okay, so this will be the V out. Okay, so I put it here is this is positive V out, this is negative V out. Right. So we going to get our objective is overall gain. We going to get the plus 100. Okay, this is our objective. We want to get plus 100. That means you need to multiply it with the minus 1 right here. So what is the value that you can choose at here and here? Apa value dia? What is the correct value that you choose? This one. Guys, can you answer that? What is the value that you're going to choose so that you can get the gain equal to 1? Union track, your name appear. What is the value? Okay. Are you still there? No. Rizwan, what is this value?
Jadi 1.5 kilo ohm dengan 1.5 kilo ohm.
Yeah. Okay. You can choose any value that you want. Okay. For example, your friend choose 1.5 kilo ohm, 1.5 kilo ohm. Okay. Any value. But it must be the same value for this one. Because this one divided this one, you got it 1. Okay. Now, for the overall gain, what you will get it here is minus 100 you time with minus 1. That's why you got it positive 100. Okay. All right. Okay. So you can choose any suitable value, but it needs to be same. Okay. That's why normally when you choose the inverting, so you will have another inverting so that you can get it when the input positive, output also you got it positive. Okay. Alright. Or you don't want to use the inverting, you can use to do the non-inverting. Okay. Any question regarding this one? Any question? Guys, any question regarding this one?
Tak ada.
Okay. Dengar pun suara akak kita. Okay, right. So let's look the non-inverting configuration. Okay. Uh, Sometimes we forgot how to draw the circuit for the non-inverting configuration. So it's a simple concept. Draw first the uh, inverting circuit. Okay, draw first the inverting circuit. Okay, this is the inverting circuit. You just need to memorize the inverting circuit. But of course lah, now it's the online, right? So you can open your lectures note. Alright, betul kan? As long that you not get TS is okay. Aizat, you got
Hmm.
TS right? No.
Ah.
Alamak, kantoi. Okay, dah lah. Alright, so try to draw the inverting circuit first. Okay, this is the inverting circuit. This is the inverting circuit. Alright. So how to draw the non-inverting circuit? You just switch this one. This one go to this. This one go to this. This one go to this. That's it for become non-inverting. So what you need to do is now I can use delete. Yep, okay. And then go delete. Yep, go. So now this one is become to ground and this one is be in. Okay. Now it's already became non-inverting circuit. Okay. Right. So in this question, it shows that V in has the input impedance. So for this non-inverting configuration, the input impedance will be like here. So the value is 1.5 kilo ohm. Okay. Alright. Okay. So and then what is the formula for the non-inverting? So V out, you got it is 1 plus R2 divided with R1. Uh, then you time with V in. And the gain is 1 plus R2 divided with R1. Alright. So in this case, you got it, the gain is 100. Now you plus with R2 divided with R1. Okay. So that's mean your value for R2 and R1, yes, you can choose any value. For example, so let's choose 1 plus 99k divided with 1k. Right? So 99 plus 1 equal to 100. So now you got the value for R2 is 99k and then the value for R1 is 1k. Okay, done. Right? So that's it. So we have designed this our non-inverting configuration is 99k here, and then this one is 1 kilo ohm. Okay. Alright. Okay. So far, do you have any question regarding this one?
Clear, doctor.
Yes, sorry.
Clear. It's all clear.
Oh, clear, Babi Tiran, right? Is it you? No.
Yeah,
Okay. Yeah. Where are you from?
I'm from JB, doctor.
Sorry, JB. Oi, ingat ke orang luar. Orang JB rupanya. So you are staying at UTM?
No,
No. Okay. Alright. So right now we have learned the two configuration, inverting and non-inverting. Okay. So let's move to another slide. Okay.
Sure.
So there's
Ada question.
What
Tanya
is
why,
it?
in the chat.
ya,
Ha,
chat tu, buang ada punya question.
Why V
apa?
minus and V plus not equals to 0? 老师看。
Ha? equal to 0. Sorry, mana soalan? Apa? What is it, Yan?
Why V minus and V plus not equals to 0?
Oh, why the V plus equal to V minus equal to 0? Is it? Sorry, I cannot get it. Apa soalan ni?
Zero. Why V negative and V positive not equal to 0?
Oh, why the V positive and V minus not equal to 0? Macam tu ke soalannya? Is it? That is the question?
Yes,
Yan, is it? Is it that is the question? Yan Zingyi?
Actually, this is the question from Shukai. Then I also don't know what he wants.
Sorry, I cannot.
Shukai wrong.
Okay.
It's the question in the chat room, actually.
Huh?
In the
Sorry,
chat area.
error? Type error?
question dekat chat doktor. Chat.
Dekat chat. Oh, sorry. So Allah terkeluar pula. Sekejap. What is it? Y di mana V plus not equal to 0. Yeah, P Kai Wong. Okay, good. Okay, I try to answer that. Okay, alright. For the non-inverting, right? V minus and V plus is not equal to 0. Why? Because of the V plus right here is connected to the V in. It is different between the inverting. V plus is connected to ground. That's why it's equal to 0. Can you get it? Did I answer your question, Chi Kai Wong? This one, positive, equal to V in. Okay? And for the OM, V plus, V minus will always equal to V plus. But in this case, our V plus is V in. Okay. And for this one, V minus always equal to V plus. So right now, our V plus is connected to ground. So that's why it's equal to 0. Okay. Alright. Good question. Okay. Let's proceed to another slide. Okay. If you have any question, you can interrupt. Okay. So that I can explain it to you, and that is the good thing for me to learn new knowledge, right? Yep. Sometimes when the lectures teach you, yep, they will teach uh, uh, based on uh, the, his old method, right? So sometimes he doesn't learn a new thing. Although that he or she already teach this subject so many years, but sometimes, yep, a new thing that he or she not figure out. Okay. All right. So the net configuration, okay, 1, 2. Okay. OM is the voltage follower. OM is the voltage follower. Okay. All right. Um. All right. So let's look. Sometimes when we have our sensor here, okay, our sensor it will produce maybe in term of voltage millivolt, and also it also have the current. For example, the microamp. Okay, very small current. Normally, our sensor or our transistor will produce very small current. Okay, and then after that, you try to put some load. For example, you put it in speaker or motor, right? So all the speaker or motor will have their own resistance here. Okay, for example, 8 ohm and so on. Okay, so we need to use the OM, right? So we configure it as the voltage follower, right? So why we need to use the OM? instead of we connected it directly. Right? Why? So let's look first. Okay. When we use the OM, so the V out here, V out at here, V out always equal to V in. That means your gain for voltage follower configuration will always equal to 1. Okay. So V out equal to V in. Right. So this is like your sensor lah. Okay. Right, for sensor. Right. We will go to this OM, right, and then it will got the V out. Okay. Alright. The next slide we explain to you why we need the voltage follower. Alright. Why we cannot directly connect it to the load. Right. So let's look at this case. Okay. For example, let's say a motor here. So it need a 5 volt. Okay. It need a 5 volt here. Alright. So it need 5 volt to operate. Okay. This is the value. Alright. And now you make a two configuration. First, you have the voltage divider here, and then you connected your motor here, and then the second part is you use the OM, you configure as the voltage follower, right? Negative to here, without any resistance, okay? Any input impedance, right? Any feedback resistor. Then you connect it to your motor here. Now you will found that, okay, you will found that the voltage that going to this motor in this configuration, alright, is 98 millivolt. Okay, 98 millivolt. However, when you use this OM, you will got it, the voltage going to here is 5 millivolt. Okay, so why? There are a lot of discussion here. So we need to know about this concept. So this is the OM have the input impedance internally will be highest, for example 100 mega ohm. Okay, so this one I can draw a little bit lah about the concept. Okay, so this you have your circuit here, and this is your load, and this is 10 volt. I just want you to get the concept. Okay, so this is 10 kilo ohm, and then this one is 10 kilo ohm, and then this one is 100 ohm. Okay, so after this, when you do the calculation to find the resistor from here, so I put it here is 10 kilo ohm. So this one 100k is parallel with 100 ohm. Okay, right? So you will find that this value for this resistance, I think, is almost how 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 going to calculate it? 1 over RT, 1 over 10k plus 1 over 100. Okay, now you got it. RT is 100k times 100 divided 100k plus 100. So you will find that the value here that you got it is 10k. Right, so I try to calculate the value first, times 100 divided with 10k times 5 as 100. Now we got it, the value is 100 ohm. So this one is 100 ohm. Then this one is 10 volt. So when you calculate the voltage at here by using the voltage divider, you will got it 99 millivolt. Okay, so that's why this motor will only get the 99.8 millivolt. 99.8 millivolt. That's why it's not enough to drive this motor. This motor need 5 volt. Okay. Right. The same concept that you use right here. So you just change here is 100 mega ohm. you will found that instead you get it 100 ohm here, then you will got it is 10k. You can try, okay, 10k. Then you will got it is here, you will got it is 5 volt, positive 5 volt. Okay, that's why we instead we use the voltage follower, right, to make sure that our load, right, can be operated. Okay. Any question regarding this one? Any question? So I need to see on the chat. Okay. Any question? Can you understand about this concept? Why we need to use the voltage follower? Boleh faham ke, guys? By look at logically, yeah, it can work logically, right? But when you calculate it, yeah, it doesn't work. Okay. Any question? Faham? Okay, good. Right. Okay. So this is the voltage follower, right? Why we need the voltage follower? Okay. And the purpose of voltage follower is, of course, is try to maintain the very small current, right? So this is very small current, right? I. So this one we can get the same I here. Okay, we try to maintain. Okay. The next configuration is the summing amplifier. So what is the application of the summing amplifier? Huh. Can somebody tell me? So it has a few input here going through one OM. Guys, anyone who going to share the example where we use this summing amplifier? Okay, let's look any participant there. Okay, only two. Okay. Hilman, are you there? Oh, are you there? No. Where this or summing amplifier has been applied? Hilman, you want to speak
Ya,
something?
ada.
Ah, dekat mana application summing amplifier ni?
Yep.
Okay. What do you think? No?
Analog signal.
Analog signal. Yes, there are a lot of analog signal application. How about Jackie Chan? Oh no, Jackie Tang. Wow, this one Jackie Tang. Where this summing amplifier has been applied? Where is the example of application? No, no answer from Jackie Tang. So maybe K Hung Fung. Wow, this is Kang Kung Fu. K Hu Fung. Ki Hu Fung. No, no answer. Ah, Kusai. Where is everybody? That's it. What happened? Okay. Anyone want to guess where is the application of summing amplifier?
Audio mixer.
Audio mixer. Yes, Patro. Thank you very much. Right. So for those who like to go to karaoke, right? So what you will have? Okay, some of your boyfriend or girlfriend will have one mic. Okay, and then you will have the another mic. Okay, and then it will go to audio mixer. Yeah, correct. Audio mixer, and then it will produce with the two audio, right? This is your audio and this is your girlfriend audio, for example. Okay, this is the purpose of the summing. It can edit two signal, right? And then it also can amplify it, is depending on this value and this value and this value. Okay, so this one it will produce one gain. This one it will produce another gain. Okay, so the formula is like here. So I just want you to remember the formula here. V out equal to minus G1 V1 plus G2 V2, and then it can edit 2 or 3 more signal or 4 more signal, right? So that's why sometimes we have a 2 mic or maybe a 2 input from another one, right? Okay. Okay. So you can have another input G3 V3 plus something something, right? Okay. But of course, you need to bear in your mind is have the negative one, right? So that's why I told you all the configuration is from the inverting, right? This is the inverting because the positive going to ground, okay? And then for the gain, so you will found that is G1 is depending, so is RF equal to R1, so G2, all right? So you got it, G2 equal to RF over R2 and so on. Okay. Alright. Now let's look the example 5.3. Develop an OM circuit. So it doesn't tell you what is it. Okay. The OM circuit. Okay. Alright. That can provide an output voltage related to the input voltage. So it just share you. Okay. Develop the OM circuit. Okay. Alright. Uh, we can know that. Yep. While looking at this, we can know that yeah, there will be two input, right? There will be two input, okay, and then one output. Okay, so we can assume that yeah, this one is the summing circuit. Okay, so what you need to do is you need to compare with the formula of the summing circuit. Okay, all right. Formula for the summing circuit. So bear in your mind, please remember V out minus G1 V1 plus G2 V2 because there are only two input. Okay. Alright. Okay. So now we can compare with the formula given. So we got it to V out 3.4 V in plus 5. Then we will compare with the summing formula. G1 V1 plus G2 V2. Okay. Alright. Before you compare it, try to bring this minus going to here. Now you will got it minus V out equal to G1 V1 plus G2 V2. Then you can compare it. Alright. So in this case, when we compare it, we got it is G1 equal to 3.4, and then we got it is V1 equal to V in. Another one, you can compare G2, I choose is 1, and V2 I choose is 5. Okay, just compare it. G1, V2 here, G1 here, V in, V1, V in, G2. So this one is 1, right? Okay, this one is 1. So this G2. So V2, I put it 5 volt. You also can choose G2 equal to 5. But for to make it easy, so just choose G2 equal to 1. Okay? Alright. Done. And then we try to figure out what is the gain for this one. So let's look G1 equal to 3.4. So G1 equal to RF over R1 equal to 3.4. So you can choose the value of RF 34 kilo ohm. Then the value for R1 equal to how many? How is it? 34 is 10 kilo, right? 10 kilo ohm. Okay, done. Okay. Then we are done that one. So let's calculate for G2. So G2 equal to 1. So we got it RF over R2 equal to 1. Your RF is 34 kilo ohm equal to 1 divided with R2. Now you can get it your R2 equal to 34 kilo ohm. Okay, done. Okay. Right. So we already got the value for RF, R1 and R2. Okay, done. Alright. So far, do you have any question? Ada apa-apa soalan? Are you writing or not? Tenang saja. That's why the online class, right? How to make the online class interesting, right? No class, is it? Don't make class, is it? No. Tak boleh, nanti tak buat kelas nanti kena jawab nanti. Lecturer don't make class. Then there is no online class through the semester, right? Guys, do you have any question?
Wang ada soalan.
Huh? Sorry?
Tanya soalan dekat chat. Dia tanya G2 and V2 can use other values.
Oh, thank you Rizwan. Kadang-kadang saya besarkan ni, saya tak nampak. Okay. G2, V2 can use another value. Wow, si Kai Wang. Okay. What you going to choose? Okay. I try to understand your question. Okay. You want to use G2 and V2. Yes, you can use, for example, G2 equal to 5, V2 equal to 1. That is the simple things lah. If you want to use another value beside 1 and 5, yes, you can do that. So that as long you can get the same answer if you multiply between G1 and V2, G2 and V2. Okay, but of course you will got it, the resistant value for G2 will be different. Okay. Alright. Okay. Okay, so let's move on. Okay, now we already get all the values, so we need to draw the summing circuit. Okay, how to draw the summing circuit? Like I said you before, everything is from the inverting circuit. So let's draw the inverting circuit first. So this is the inverting circuit. Okay, positive and so on. So this one is the okay. Aizat, so what color that you want?
Kuning.
Huh?
Kuning.
Kuning. Apa kuning? Kuning betul. Otak kuning ni budak ni. Okay, be out. Sorry guys, so you need to Aizat ask for kuning. Be out. Payah Aizat ni color tak ada taste. Kuning pula. Choose another color.
Hijau tu macam kereta dia.
Hijau. Okey. Okey, hijau. Ya. Hijau, kuning. Good. Kedah. Alright. So, this one you already draw the inverting circuit. This is the inverting circuit. I put it is RF. Then this one is R1. Okay. Then, that's mean this is your first input. V in. So because we know that the summing have a multiple input, so we can put it as the V1. Okay, V1. And then how about the another input? So you just take it this point, right? This point, then you can draw another input. Okay, here V2. Okay, and then this the value is R2. Right, done. You already do the summing circuit. If you got it another input, for example V3, so you just added this resistor. Okay, so this one is V3, then this one become R3. Okay, right. So the formula, if you got it this three input, so it will become V out minus G1 V1 plus G2 V2 plus G3 V3. Okay. Now is G1 equal to RF over R1. Okay, and then G2 blah 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 lah. Okay, this is in case you have multiple input. Okay, alright. So let's say okay, delete. Okay, alright. Okay, that. So in this case we only have two input. Okay, done. We already do this. So let's put the value 34K, 10K. Alright, this one 34K. This one is 10K. This one is 34K also. Okay. Alright. So for this formula we got it is here V out B1 B1 plus G2 B2. Right. But for this case we don't forget it we not forget about this one. This one you put it is okay, you put it minus V out. That's mean this one will become your minus V out. Okay, but this example we want a positive V out. Positive V out here, positive V out. So what should you do is you need to uh, put it another amplifier, the inverting amplifier. It will invert it. So this one, okay, this one and this one here. And what is the value that you can choose? You can choose the 1K and 1K or 10K or 10K. Now this one you got it is positive V out. Okay. Uh, right. So you have complete the circuit for summing. Alright. And then you got the answer. Okay. Any question regarding this example?
Betul?
Yeah, is that yes?
Yang second circuit tu memang resistor dia boleh pilih je value apa-apa.
Boleh, tak ada masalah. You need to choose the same value.
Oh, okay.
10K, 10K ke, 2K, 2K ke, 1.5, 1.5 ke. Alright,
Okay.
boleh. But try to choose this value. K, K, kilo ohm.
Oh, okay.
For 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 eliminate the loading effect. If you choose 1 ohm, 1 ohm, when you do it practically, so you will found that the value will be dropped from here, okay. Alright. Okay. Dah boleh mute tu. Okay. Alright. This is the summing done, inverting done, non-inverting done, voltage follower done, summing done. Okay. Then we go to the differential amplifier. Okay. Differential amplifier is to differentiate between two input voltage. Alright. Bear in your mind only two input. Right. So that means you only got the two input here and then it will differentiate. Okay, that's it. Right. To find the formula, there are a lot of steps need to be done here. Blah 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 blah. So to make it simple, right? To simplify it, so when you design the what we call it the differential amplifier, make sure these two value is same, right? Two value is same. Okay, here and here is same, here and here is same. Okay, here. Alright, this is the concept lah. If you don't choose these two value not same, so you need to use this formula. Okay, alright, you need to use this formula. This formula. Okay, so in this case you don't choose any same value. So to make it simple, let's choose the same value. That means you just need a two resistor. So the formula will be like this one. Okay, this is the formula. RF over R1, V2 here minus with V1 here. Okay, so V2 that means is at a positive minus with negative. Okay, V2 minus V1. And RF value is this one, and R1 value this one. So RF and this RF will be same, R1 and R1 will be same. Okay, so let's look another example 5.4. A sensor output a range of 20.0 to 250 millivolt. Okay, so that's mean you have the output. Okay, so we don't know the input whether it detect temperature or what. Okay, and then develop a signal conditioning so that it become 0 to 5 volt. Okay, so right now you want to develop a signal conditioning. So this is the requirement that you want, 0 to 5 volt, right? Based on the output sensor, 20 to 200 millivolt. The circuit must have high input impedance. Okay, when we talk about the high input impedance, so this one we involve the voltage follower. Voltage follower. Okay, because the voltage follower try to cater the issue of the loading and also the high input impedance. Okay, good. Uh, Identify blah blah blah. Okay, this one when you try to convert between the sensor, this is your sensor output, and this is your signal conditioning OM lah. Okay, right. Then we got it this one line. Then after that you can get the equation from the V out signal conditioning is 21.74 V in minus with 0.435. Okay, this is the question. Okay, we're going to get the question lah before we can design our signal, our differential. Okay, amplifier. Okay, in this case, this is the formula that we got it. All right, so V out equal to 21.74 V in minus with 0.435. Right? Then you can compare with the differential equation, differential amplifier if you want to use the differential amplifier. V out RF over R1, V2 minus V1. Okay, right. Then we know that the circuit will be like this one, so you can draw, get the idea. Okay, this is positive, so of course is a V2, negative is V1, then it will have the pull down resistor here, and it will have the feedback resistor here. So this one RF, so this one also RF, this one R1, so this one R1, and this one is the V out. So V out will be positive. Okay, according to this formula. So in order to compare between these two equations, so bear in your mind this one, okay, is outside the parenthesis, this one. Okay, so you need to factorize this one first. Factorize first. So what you need to do is from this one, the V out, it's become V out 21.7. Then you need to time with V in minus 0.435 divided with 21.74. Then you got it, the equation V in minus with 0.02. Okay, then you can compare each other. So you can get it is RF over R1 equal to 21.74. Okay, step 4, draw the circuit, already draw. And then what can you compare again? V2 equal to V in, done. And then take it minus V in minus V1 equal to minus 0.02. This one you need to be careful. Okay, equal to 0.02. Okay, done. Alright, so alright, this one you can find the value for RF. Take a look, 2174 divided with how many? 100. Okay, equal to 21.74. So you can take the RF if you want. RF is 2174K, and R1 you can take the 100K. Okay, done. Then we can draw the circuit like this one. The value is 2174K, and R1 is 100K. R1 also 100K. This one is 2174K. And then you will got it, your V out, you will got this equation. Okay. Alright. Any question regarding this one? No? Yeah. Okay. V1 is input is 0.02, and then the V2 V2 is equal to V in. Okay, V in. Okay. All right. For the question of input impedance, what it mean is how to rotate this one? Rotate. Okay. It mean you need to use the voltage follower. Okay, let's draw the differential amplifier first. So this is the differential. So this one is the V out, and this one your RF. So R1, R1, RF. So we already got the value for R1 and RF here. So what you need to do is you need to put it the voltage follower. Voltage follower is become like this. Negative is go to this one. Okay. Negative, positive go to this one. Okay. Now this one will be your V1, and this one will be your V2. Okay, the value for V1 is 0.02. The value for Vin will be V2 is Vin. Okay. Alright. This what we call it, try to cater out the input impedance issue. Okay, so you added the voltage follower. Oh, sorry. Okay. Sometimes some of you think that can we put the negative value? Yes, can. You can put the negative value here. Okay. The voltage can be negative. Okay. If you do some previous uh, test one, you will see that, yep, you can input the negative value, right? So sometimes you can put it, you can input a minus 0.02 volt. This is okay. We can generate the negative voltage, right? So if you want to make it positive, you need to put it another inverting amplifier. Okay, no questions so far. All right, let's proceed. Okay, voltage to current. Yeah, normally we use that, and normally we don't use that, right? Depending on your application lah. So this is the way how you convert from the voltage. You can get the current here. There are complex circuit there, right? So this is the question lah. Okay, I'm not going to go on detail about this one lah. And how to convert from the yep, there are one more, you can use the inverting amplifier to get the current, this one. Okay. Current to voltage. So this is the circuit. So in a simple circuit, you can get it the current from here, and then the voltage from here. Okay. All right. You want to take a break for 5 minutes before we can continue the last topic. Okay. How about that? Take a break for 5 minutes. Is it okay?
Goodbye.
Okay, goodbye. Okay, good. Okay, welcome back. Guys, are you still there?
Tidak.
Okay, so let's continue. This will be the last topic for today lah. Okay, alright. Let's me recap back. So we have learned the OM. Okay, first is inverting, second is non-inverting, and then after that what? A voltage follower, and then summing, and then differential. Okay, for the voltage and current, this is your for your general knowledge lah. Right. Normally we don't test this topic during the test one. Okay. Uh, After we do some signal conditioning like non-inverting and so on, etc., etc. So sometimes we want to convert it into digital value. All right. So before this, we just look the analog value. Okay. And then sometimes we want to convert into digital. That's mean only one or zero, or it will represent only two value, whether it's 0 volt or whether it's the 5 volt or 3.3 volt. Okay. And sometimes we want to make an alarm system. For example, you have the sensor, you have the inverting circuit, or maybe the non-inverting circuit, and then you will put some component, we call it is comparator, and then it will trigger an alarm. Okay, so for comparator, if we compare between two voltage, and then it will give you the output only two output, right? Whether is high or zero. Okay, this is what we call it is digital output. Okay, alright. Uh, the quite popular one is the comparator is LM324N. This is a very long time ago lah. Okay, so the symbol is same like the OM except it start from positive and negative here. Okay, and then normally I like to rename this comparator as the V in here. You can see the V in here, and also V reference. V reference that means you can change this V reference depending on what the limit that you're going to set up, right? Okay, and then the concept is if the V in here, alright, put here, I will put here. Okay, if V in is more than V reference, so the output will be 1. Alright, if your V in is less than V reference, the output will be 0. Okay, that is the concept. So what is mean 1 or 0? This inside your coding, right? Inside your coding, that's mean the digital value. Okay, if you set the reference, the supply voltage you said is 5 volt, and then the another one you said is minus. So the digital value is 1, is actually it will produce 5 volt. Okay, the digital value 0 actually will produce 0 volt. Okay, that's why I told you there will be only two value. Right, when you play around with when you heard about the digital value, so then in your mind, yeah, it will give you only 1 or 0, or maybe it will give you only two value of voltage, whether 5 volt or 0 volt, depending on what you connected to this one. So when you use the Arduino and microcontroller and so on, there are a lot of comparator there. Okay. Alright. So let's look example 5.4. A process control system specifies that temperature and pressure should never exceed 160 degree and 10 kPa. Design an alarm system to detect this condition using temperature and pressure transducer with transfer function, okay, of 2.2 millivolt and 0.2 kPa. Okay, this is the uh, the answer. The question is about. Okay, let me open. Okay, I already open. Okay. Right. Okay, so on this question we can get it. We can get the uh, an idea about it. Okay. Okay. Temperature and pressure. Temperature and pressure. So there are two parameter. Temperature. Okay. And the other one is pressure. Two quantity that you want to measure. Temperature and pressure should never exceed 160 degree, and pressure should never exceed 10 kPa. So it told you that these two quantities should never exceed each other. That means temperature and pressure should never exceed. Okay, right. So how to draw the comparator circuit? Okay, for case a temperature sensor first. So this is your comparator. The triangle also the symbol is triangle, but it will start with positive and negative. Right, and then it have a three leg here, right? And then the output we put it is out one. Okay, it's not the V out. Okay, it's the out one. Okay, and then this will be your V reference, and then this will be your uh, V in. Okay, I put it here. Right. So then we got it. Transistor is connected to the transistor here. Then the transfer function or sensitivity of the transistor will give you okay 2.2 millivolt per degree. Okay, that's it. So what you can understand about it is the output is millivolt and then the input is degree. Right. So now based on this question, right? So, or we're going to develop an alarm system so that the temperature cannot exceed 160 degrees. So, we need to put as our reference 160 degree. Okay, and of course, this one is millivolt, so we need to compare it the voltage also, right? This one the voltage, the voltage. So, how to find that voltage? So, we can write it here. Uh, V reference, to find the V reference is 160 degree. We time with the transfer function 2.2 millivolt over degree. Now the answer you got it 0. I put it here is 352 millivolt. Okay. Yeah. In this case, what you need to do is you need to connected here or any source, right? Any sources, maybe you can put it at any sources, right? So the sources here is 352 millivolt. Okay, normally we will use the potential meter. We will use the potential meter to adjust this voltage, right? So that we can get the reference voltage that we want. So in this case 352 millivolt will represent 160 degree. So if you want to set the alarm system to 100 degree, that means you need to 100 degree. So you need to set this one is what is it? 220 millivolt. Okay. Do you understand what I mean? Boleh faham?
Tak faham sangat tu.
Ha? Macam mana?
Faham. Tak faham sangat.
Tak
Tak faham.
tak faham sangat. Tak faham sangat. Okey. Uh, dekat mana yang you tak faham? Dekat mana?
Kan dapat 220 millivolt tu.
Okay. This one. Okay. Alright. Let's say we want to set our limit for the temperature, right? Is 160 degree. And then we time with the transfer function lah. Ini transfer function transducer. Then we got it is 352 millivolt. Okay. This one you understand, right? This one.
Yes, saya ni faham.
Okay. Uh, Okay, for example, if you want to design your alarm system, or if you want to set your temperature only at 100 degree, so that means you need to time the transfer function of your sensor is the same transfer function. So you got it to 0 millivolt.
Yeah,
Ini
okay.
faham?
Itu faham.
Okay. That
Then,
means
100 degree Celsius sebab dia 160 degree Celsius tu dia punya reference.
yes,
Betul.
betul.
So dia tak boleh hit at 160 degree Celsius lah when anything less than
Yes,
that.
yes, betul. So if we want to design our alarm system at 100 degree, then we need to change this value. Okay, faham Okay, this one faham this one? Right. Okay. In this case, in the example, we set 160 degrees. So we need to use this value. Okay. So this value will represent 160 degree. Okay. Right now, let's look a certain cases. Okay. For example, at 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 one condition, it detect uh how much is it? 150 degree. Okay, 150 degree. So 150 degree, 150 you time with 2.2, you will got it. It's here is color ni tak best. What color is it? Aizat ni pilih color yang cerah-cerah. So this one you got it is 330 millivolt. Correct? Right. So what happened in this case? In this case is 330 millivolt is less than 352 millivolt, or it means your V in is less than V reference. I'm right? Okay. So what happened to your V out? What value you will got? 0 or 1?
Bro.
Okay, now you will got it. This one is 0. Okay. So for example, at one condition, you got it, your temperature is 160 degree. Okay. Now this one is became 352 millivolt. So 352 millivolt is more than, okay, I put it here 330 millivolt, 52 millivolt, sorry, 52 millivolt is more than 352 millivolt. So the output will become 1. Okay.
Kalau nilai dia sama, dia anggap sebagai more than the reference.
Yes.
Kan?
If the value is same, so yep, if the word is more than lah, right? So that's why we got it 1. Okay. Any question this part? Do you have any question? Everyone? How about
Faham
this
saya
one? Faham Okay, good. Okay, siapa yang kata tu? Faham tu. Okay, now we have settled the temperature. So let's do the comparator. So comparator, that means it need another the pressure, that means it need another comparator. So comparator have 3 legs here, and then what color is it? Okay. So the output here will be output 2. Then this is the V reference, right? This is the V in. Okay. Then it's connected to the transfer function, okay, of the what we call it, of the pressure. Okay. So in this case the pressure is 0.2. Nak tukar color juga. Okay. Dr. Syahri ni cip dengan color je. Sorry adalah sikit improvement Don't forget to write in the EPP. Dr. Syahri always play with the color. Make me sometimes confused. So this one is volt. then this one is kPa. Done. So in order to find the V reference, this one V reference is equal to, now we're going to set our pressure limit at 10 kPa. So 10 kPa, now you time with 0.2 volt over kPa. So in this case, you got it is 2. Okay, 2 volt. Right? Okay. Then that's me. Your V reference here, you said it is 10 kPa, the limit. That's mean you need to connect it to another sources, right? Another voltage is equal to 2 volt. Okay. Right. So let's look the condition happen here. Condition. Okay. For example, if you got a pressure is 5 kPa, right? And then you will calculate the voltage here. Then you found that the output that you will got it here is 0. And right, because 5 kPa is less than 10 kPa, right? So if you got it another condition where you got it is 11 kPa, for example, okay, or 10 kPa. So now you we got it here is equal to 1. That is the concept. Okay, can you get it? Because 11 is more than 10 kPa. This one clear? Clear, right? Okay, and then we need to combine for both comparator. So how to combine it? So it will become like this one. So kalau ni boleh cepatkan syok Okay. Now, okay, so what is the 2.2 millivolt per degree? And then this one is what 0.2 volt per kPa. Okay, now this is the V reference is 352 millivolt. So 352 millivolt, and then this one is 2 volt. Okay, 2 volt. So this is your temperature, and this is your pressure. Okay, done. Then you will got it the output 1 and output 2. Alright, so this is the second, the last part, right? In order to develop an alarm system, so what you need to do is you need to put another component. We call it the gate, right? In this case, I put it this one. What is it? This one. This one what? This one is
Diode.
AND gate. Right. So we got a two gate here. Is this one is the OR gate, right? This one the AND. This one is OR gate. Okay. So what is mean AND and OR? AND that's mean you multiply. OR that's mean you plus. Okay, remember during your programming class. Okay, right. So this one you we got it is alarm system. The output is alarm. Okay, right. Okay, so and then we can develop a truth table for the we call it the different condition lah, different possibility. It can be different possibility. Output one, okay. Output 2, okay, and alarm. So how many condition that you will see that it depending on the output of this one, it will be only two condition lah, 1 and 2 here. So that's mean 2 power of 4. That's mean will be 2 power of 2. Okay, 2 power of 2. There will be 4 conditions, right? Okay. So you can write that. Okay. For example, let's say the output one is 0. That means the temperature is not exceed with the reference. Okay. And then the pressure is not exceed with the reference is 0. So what alarm that you will get? If you use the AND gate, you need to multiply 0 times 0, 0. Right? Okay, let's say the condition is temperature is 1, temperature exceed, and pressure is not exceed 0. What the alarm will be? You multiply. So this one will be equal to 0. And the temperature not exceed 0. Pressure exceed 1. So 0 also. Alarm not trigger. And then temperature exceed, pressure exceed, so alarm you will get 1. So it will trigger the alarm. Okay. So this is based on the need or requirement that we want. So we want the requirement is temperature and pressure cannot exceed their reference value. If the both is exceed, so we will trigger the alarm. So this condition we describe the uh, the what you call it, the condition that depending on our need. Okay. So far, do you have any question? Ada apa-apa soalan? Is it clear to all of you?
Clear, Dr. Clear.
Yeah. Okay. Guys, any question regarding our lectures today? Have you eaten?
Dah.
No? Sudah. Okay. Shi Kai Wang, do you have any question? Are you guys or girl? Are you boy or girl? Jackie Tang, I know. Jackie Tang, boy. Oh, Jackie Tang. Okay. Pang Hoi Tang. You from Malaysia, right?
Yes.
Okay. Alright. Good. Good. So, I think that's it for our class for today. So before that, so let's look uh, previous test lah for you. Maybe it will be good for you lah to be prepared, right? Yes. Alright. This is the previous semester about the test one. Okay. So uh, this is type of the question lah. For example, using the level measurement system, so you need to explain for the each component. So like the example that I showed to you about the uh, pressure measurement. So you have the gauge, right? The pressure gauge and so on. So sometimes the question need to be, yeah, you need to be try to imagine the system, right? The component itself. All right. And why the important of instrumentation system? Okay, why is important? Aizat, kenapa penting instrumentation system in manufacturing or production?
Hmm,
Habis lah Aizat kan, kena tanya je.
untuk dapat data yang accurate.
Okay, correct. Okay, when we talk about the manufacturing or production or some industrial, so the keyword is you need to know about, you want to monitor first, and then after that you can control. Okay, and then after that you can, the purpose is you want to tackle out the safety. Okay. So when you able to monitor, yes, and then we can control. That mean we can control our production lah. Okay, let's say that your company is develop a bottle, for example. So we need to use an instrumentation to measure the size of the bottle, right? Every time daily operation. And of course, if something happen with your machine, you will have some sensor to measure, right, to be precautious about the machine. So this one, right, to achieve the safety, right? Okay. And then three important to knowing about the performance characteristic. So we have what we call it static. We have the first one is operational. Operational is just you to know on how to choose a transducer, right? Because that one you have range, resolution, and so on. And then the second part is we have the static. Static involved with accuracy and error and so and what we call it calibration and so on. This is a static. So you're going to know what is the performance of that transducer in terms of the accuracy and so on, right? And then after that, you will go through to the dynamic characteristic. Dynamic characteristic, you want to see the response, right? How fast your sensor can detect, right? Is it your sensor is behave on the first order sensor? Is it behave on the second order sensor? Right. This is the important thing to know about the transducer. Okay. All right. And resolution, this one you can find that first order characteristic. Yep. You can describe. Okay. What is the first order? You will have some of the time constraint and so on. Okay. And then question two is about your signal conditioning. All right. So what is this circuit? Can somebody tell me what is this? You got the three input, then you got the OM.
Local.
Yes,
Some
ada?
amplifier.
Summing, yes, summing amplifier. So this is what we have been learned today. So you will have the V out minus G1 V1 plus G2 V2 plus G3 V3. Okay, but don't forget to bring the minus V out here. All right, done. And then after that, if you want to design, so maybe you will need some another uh, inverting amplifier, right? Maybe lah, but in this case is ask you just to write the equation, right? The VR equation. So it's okay. And this one, what is it? What do you think? What type of the? Yep.
Non-inverting.
No. Non-inverting. Uh, non-inverting. Yeah. Yep. No. Non-inverting. This one is going to ground.
Differential amplifier.
Yes, because you got it the input to input, so this one we call it differential amplifier. Okay, so you can solve this one. Alright, and then so how an inverting amplifier input? This one is show you how to design the the inverting amplifier. So the inverting amplifier. Okay, so it gives you the input impedance 1.2. Yep, right. Then you can sketch the what we call it the inverting. Alright, and then figure two is about to develop a system, monitor or an alarm system, right? An alarm system, right? So you have two parameter that you're going to look at. The first one is temperature, then the second one is humidity. So it's already give you the transfer function. Okay, that's it. And then this is the value that will be your reference. Okay, so you can calculate your reference voltage based on this value. Okay, this one you calculate. Okay, and then after that you will have a two comparator because there are two parameters, temperature and humidity. So your answer must include. So what is the requirement? The system will monitor feasibility data without requirement, blah blah blah. It can generate design automatic navigation system. Your system must have include something. The body temperature should never exceed while. While, kataan while tu Hmm. Wow. Manakala. Okay. So while that's mean if we use AND or OR gate, what do you think? AND or OR gate? Let's see the schematic. Oh, wow. Why? I think while is all lah. Okay, all gate because uh, it is quite difficult to know that the temperature and humidity is increased together. So now in this case, we need to remember. Okay, if the humidity increase, it will trigger an alarm. If the temperature is increased or exceed the reference, it will trigger an alarm. So that's why you will use the OR gate, right? And then the OR gate, the condition, it will be like this one, out one and out two, and then this one is alarm. Okay, so there will be four condition, right? Because you will use the OR gate, right? There are two input there. Then this one will be 0 0, the first condition, this one the second condition, third condition, and fourth condition. Okay, if you do all it, that means you need to plus. So the answer will be 0 plus 0 0, 1 plus 0 1, 0 plus 1 1, 1 plus 1 2. Is it correct, guys? Is it correct, this one too?
One.
Okay, no. Okay, it will be 1 because this one is the digital value. Digital value only 1 or 0. Okay, right. But in the real uh, in the real pr- uh, in the real voltage, right? In the real practical, you will got it. This one is 0 volt, so one is maybe 5 volt if you connect it to the supply 5 volt. One 5 volt, this one 5 volt. Right? In the real lah. Okay. Alright. So some of you ask upload test one ni. Okay, I will upload it. So you want to make it as the assignment or not? This one. Budak-budak ni dengar je assignment. No. I don't want to. No. Alright. Okay. So it's okay lah. So just your for your exercise lah. So I don't want to make it as the assignment lah. Okay. Because you already got the one assignment, right? Okay, that one. Okay. So try to make it as the exercise for your test one. Oh, signed by Hong. Good. No assignment. Good. Okay. Alright. I think that's it for Aizat say tak nak. Okay, K tu need to put om. Tak nak om. Okay. Alright, good. So that's it. For today class, do you have any question before we end our class for today? No? Okay. I think that's it. Thank you for your attendance, and then I will see you again on next week, inshallah. Right. Okay. Any question, you can WhatsApp me directly.